A four-note, a correction to the coming video at 2:40 to about 3:15 in the video, discussing the Warren lockout hub, which is not original. And with that Warren hub, WARN, these pieces should not have been reinstalled, and they were years ago. This is a piece that goes back in over top of the outside of the outer bearing, and the spring bears against it like that. And if this is put in backwards, here's the disaster that happens. So with the Warren hub, these parts were never supposed to be reinstalled. These parts show up on the Chilton manual for the original 70s series, but these should have been taken out, so they're not neat on either side. They don't do anything. Here's the hub on the wheel of the front of the 78 Chevy Blazer and other similar vehicles. There are some serious tricks to assembling this correctly and getting it aligned correctly. And the procedure that everyone's talking about, tightening the inner nut back in there to 50 pounds, backing off and tightening to 35, is wrong. That is torque. The entire purpose of the procedure and the procedure to correctly install these bearings is to get a clearance in the bearings so grease will fit in that clearance and lubricate. Insufficient clearance, the bearings will burn up because of no grease. Excess clearance, the bearings will be destroyed because the wheel vibrates. The clearance depends on the kind of grease, the thickness, and the temperature. Why torque is wrong? Well, torque is these nuts, like this outer locking nut. That's a nut with a round outside and 4 spanner ears. And up inside there, you might be able to see the threads on the axle. There's an inner nut down inside there, and there's a pin on the face of that nut. That nut is what sets the clearance, or lack thereof, on both the bearings. The reason we cannot use torque is because torque is extremely dependent on thread condition. Are the threads clean? Are they damaged? Is there debris in them? Is there grease in them? Just a little bit of grease will result in the same 50 pounds of torque, putting a tremendous more axial force on the bearings, because the torque is not devoted to also overcoming the thread friction. There's basically 2 ways to torque fasteners with regards to the threads, either clean, dry threads, or threads lubricated with something, oil, grease, Loctite, whatever. The oil and the grease and whatnot reduce the friction on the threads. Loctite's coefficient of 0.1. And all that energy of the torque is then devoted more or less to causing axial force that pushes the bearings together. It's impossible to know what the condition of the threads are in there, especially with grease on them. So torque is unreliable, and torque has nothing to do directly with bearing clearance. Now there's a serious gotcha here. This truck, I almost lost a wheel on the other side this morning because the bearings came loose, because the bearings were acting really funny and just would not tighten correctly. This truck has a Warren locking hub on it. Back there's the locking assembly with the teeth, and there's a spring. That spring goes back inside here and pushes out to keep that assembly pushed out so it can't jump in and grab the teeth on the axle. I had put this ring in backwards. This ring looks like it's supposed to be a seat to catch the end of the spring inside here. That's wrong. And if this is put back in like that, the inner race of the outer bearing tries to grind it away. See the marks? So that goes in opposite what it looks like. It goes in with the hollow, the recess of this ring, to the inside, not the outside. And subsequently, the rotating part of the outer bearing has this clearance in here to run in. So I had that backwards. On the far side, it actually damaged it. It actually cut this ring, and the bearing stuck it up and extruded it and made a mess. So I got to find a new one of those. The purpose of tightening this assembly, assuming it's all in there, already greased, this one's reasonably close, but without taking the wheel and the brake caliper off and taking the hub off, assuming everything's greased up inside there. If it isn't, if it's been years since it's been taken apart, take the wheel off, brake caliper off, take the hub off, take everything out. Don't take the seal and the rear bearing out unless the bearing looks damaged. But clean all the grease out on these threads on the axle shaft. Make sure they're spotlessly clean. No grease, no metal fragments, no nothing. Same with the nuts. Clean them with solvent. Clean all these threads with solvent. Pack the inside of the hub back there with grease. I'm using a NGLI 0.5 instead of NGLI 2, which everybody else uses. It's a power transmission grease, extremely sticky, and it's for high loads. But regardless, when this is put together with that nut back up in there, and here's the required special socket with the 4 ears. What happens when that nut is tightened, if there's no grease in the assembly, then that nut will be tightened and tighten, and suddenly stop when the bearing rollers touch the races. No clearance. No lubrication. That's zero clearance. When that happens, the outer face of that nut that we're looking at with regard to this outer shoulder of this hub, that outside face of that nut will be the furthest away from the face of this hub possible. So what we do is we take a precision piece of flat. This is a machinist parallel from Harbor Freight. They sell a machinist parallel set for about $30. But lay that across there after scraping debris off the outside of that hub. See the trash coming off there. Scrape off the old rust and junk, because we're going to be doing this to a couple thousandths precision. Lay that on there and hold it. Then if you have a dial caliper, reach down in with the tip and set the tip on the face of that nut back in there and measure the distance from the face of that flat bar down into that nut. And that's the distance in from this face of the hub down to that face of the plate. When there is zero clearance in the bearings, then the goal is to then get grease in the bearings, which then takes up space, which means that when we tighten this down, if we just tighten that nut, there's going to be grease between the rollers, and we have no idea what the zero clearance depth is. So you've probably heard of tightening the inner nut while rotating the wheel. That is wrong. To do this correctly, put the fancy dancy socket in here over that, and notice that indexing pin down in here needs to clear the inside of that socket. It's possible to put this in crooked and hit that pin, but put this in and catch it in the 4 notches, and with a ratchet slowly tighten this. If it's tight, loosen it and then tighten it again. But at the same time, rotate the wheel like this, back and forth, back and forth. Make the lug nuts move about an inch around the circle. Don't rotate it continuously. That just keeps dragging grease in the bearings. But what this back and forth does, at the same time this nut is tightened, is that pushes the grease out of that contact between the roller and the race on both bearings, and allows you to find essentially the zero clearance without taking all that apart to clean all the grease out. It's not exact, but it's close. And when the bearings are down to zero clearance, this socket will be rotating and just come to a dead stop. You'll know it. Once that's found, then we can use the precision parallel strip and the calipers to then loosen this nut a very precise amount. I've On the other side, I've rotated that nut backwards till it has moved out 10 thousandths of an inch. And with this method with calipers, we can do a very accurate measurement down to about 2 thousandths of an inch instead of guessing with a torque wrench, because that's all we're doing is blindly guessing if we're adjusting this by torque. Now, if we happen to find a good figure for bearing clearance, then we can set this exactly that, and there's no guessing, there's no backing it off and retorquing, because when you back it off, then the whole thing comes loose again and just undid what you just did by trying to tighten it down with the grease in it. Once that's set, put this plate over it. Notice the big key up here in the end of the axle, the dead axle right there. There's a corresponding notch this fits into, and one of these holes in this plate have to coincide with that pin right there. If it doesn't fit one way, notice how that square notch is not centered on the holes. The reason is that if it doesn't fit this way, take the thing out and turn it over, see if it fits that way. If it doesn't fit either way, find one's closest and back that nut off just enough to get it into the closest hole. Because realize we're after precision here. We're not trying to guess. You sure don't want to make it any tighter. 10 thousandths isn't a huge amount of clearance with grease. So if anything, make it just a shade looser. But the distance between two of those holes that's about a 16th of a turn. I don't know what the thread pitch is. You could measure it. I'm guessing it's 60 thousandths. So backing this off by one hole causes that nut to back out just maybe 4 or 5 thousandths. So it's very fine. Then once that's done, be absolutely sure that that little pin is inside one of those holes by putting this in, and make sure when all these flat faces on these parts are put together, there is no grease on them and no grease on the threads, because that grease is sticky and it takes up clearance. And if you put this together with grease in between these parts, the grease gets hot, it comes out, all these parts are loose. I've been fighting that problem for years and didn't know why. Now I do. But all the faces of that inner race of the outer bearing, that nut in here, this anti-rotation plate and the outer nut must be clean, no grease. So put this in, back in there, make sure the big keyway fits and the pin fits in the hole, and reach back with 2 fingers and try to rock it. It should be laying flat against that nut in there. Measure the thickness of the plate and our rotation plate and its outer nut. My measurements are the anti-rotation plate is 0.117 inches thick and the nut is 0.38 inches thick. Since you know the distance from here to the face of that nut, measure it finally. Then when you put this anti-rotation plate in and this outer nut, run them down, and this distance from here then to the face of the outer nut will be decreased by the thickness of this. So take this measurement you made from here to there and subtract the thickness of these 2 parts, and then measure from the outer face of the hub to this, and the measurements better be the same after these are subtracted. If not, maybe this plate is cocked or something's bent or damaged. So this is a lot more complex than just guessing by using a torque wrench, but this is guaranteed to get a certain bearing clearance within a couple thousandths accuracy, and it's not real easy to use calipers back in here. You got to be very careful. A better thing would be a plunger type depth gauge. They make special calipers like that, but I don't have one. So if you don't like 10 thousandths, make it 15. Maybe if you back it off on a plate, maybe it'll be 15. When I did it at 10 with the wheel off, I could grab these edges of the brake rotor and I could just barely feel any movement, and very smooth. I could just take a finger like this without the wheel on. I could just touch the lug nuts and just turn it like that. So perfect feel. So that is going to drive you up the wall first time you try to do it, because it's difficult to hold this across there and also work the calipers with the other hand. You might want to have a helper hold that on there, but make sure to scrape this surface out here clean of the rust, else you're measuring the thickness of the rust also. So that is how to do this the correct way. When finally assembling this, there's nothing to hold that outer nut. There's no retaining features to hold it. So part of the reason for having no grease on these threads is that when you're ready to put this together and put it back together and drive away, take this nut and coat about 2 or 3 threads of that with low strength Loctite and thread that in, and it's probably okay to tighten to 50 pounds and let that Loctite set up overnight. That saved me this morning possibly having a wheel come off the vehicle. So there's no cotter key or pin that holds this outer ring on, so Loctite it. Low strength Loctite can be taken off with just a 1/2-inch drive ratchet. And I checked this procedure against my wife, who's a mechanical professional engineer, and we gave it a nod based on getting it done here, both sides, and taking it out and testing it.